Good morning, good day, and good afternoon, depending on where you are from. Welcome to our webinar on why is the Lisa X 3D printer perfect for engineers. I would like to welcome you everyone, and please type hi in the chat. And also on the right hand side, you have a possibility of asking a question. So please use questions feature in order to ask a question. You can upvote questions that you'd like us to answer. The Q&A session is going to be at the end of this webinar. Today, together with me, will be Dominik Stasiak, our International Channel Manager, Jakub Malec, our Application Engineer, and Valentin Holz, Sales and Key Account Manager for BASF for JM. So yeah, what we are going to talk about today is what follows. So we are going to try to answer to the question: is better to outsource SLS 3D printing or owning a printer? What are the specific requirements for 3D printed parts? And also how engineers can benefit from owning Lisa X, and how does Lisa X work, as well as some other details regarding owning the system. So yeah, let's start with the first question. So please, Dominik, take it away.
Thanks, Radek. Hello, everyone. Great to be here with you again. Regular meetings, sometimes more often, sometimes more frequently, but great to see you. We see lots of you welcoming us, saying hello. So great to have you here. We decided to focus today a little bit on very specific questions. We tried to look from the perspective of an engineer, look at our solution, how can Lisa X can be useful. And when you are thinking about this printer from this perspective, you need to put it into perspective of other solutions that are around, that are available as well. One of them is, of course, outsourcing of 3D printing. I guess many of you have been using or are using the help of service providers for doing the projects in SLS 3D printing. And actually, I have to say it's a great solution for SLS. Many of our clients, before they chose Lisa or Lisa X or Lisa Pro, they were also going that way. But there are also some problems on the way that are worth considering before making a decision if you would like to go this way or if you would like to start thinking about owning Lisa X or any SLS 3D printer in your workshop on your own. First thing is the prolonged lead time for delivering your printouts. Usually it is between 2 and 7 days. When you are doing projects which don't require high pace of delivering prototypes, it can be acceptable. However, I guess most of you know from life that whenever the project is going closer to an end, the pace start to be higher, and you need to start delivering another iterations of the models of the printouts much quicker and much more frequently. And this is the biggest issue, I would say, when you are comparing services of a service provider versus having your printer here in your office. Difficulties in fast iterations. That's the thing. If you are at the phase of project when you need to start delivering projects and start making new iterations every day, the help of service provider will not be efficient enough. Delays in projects are results of that. So if you are not able to keep up with the iterations every day, then you will have a step back from the critical path of the project, and it can have serious consequences for the project. The other problem that we noticed in such solution are the problems with communication. So sometimes it's not that easy to explain what are the most important features that you would like to keep in your printout. Sometimes it depends even on positioning of the model. If you position it horizontally or vertically, it can influence the final properties of the model. And this way, problems with communication can influence also your whole project. What, on the other hand, what Lisa X is giving, what are the possibilities offered by owning this printer? So first of all, it's shortened printouts lead time. Lisa X is very fast. I will mention about it in a minute. Most of printouts with full bed you will be able to achieve in about 24 hours. So not every time you are printing the full bed of printouts. Sometimes it's enough to print just this particular model that you are working on. It will be much less than that, but maximum print time for PA12 is 24 hours. A lot of prints with different parameters in one print job. This is something that Synterit Studio Advanced, so our software, our slicer, is offering as well in its advanced version. My colleague Jakub will be covering this topic later on, so he'll tell a bit more. But just to give you a clue, you are able to modify the settings for different models set in a single print job with this software. And the last possibility is the faster iterations of design. So, like I mentioned, you are able to print a new version of the project every day with Lisa X. Now, what is the speed? This is 14 millimeters per hour in z-axis, measured for PA12 material, so the most commonly used one. This is ultra fast. Lisa X is considered to be the fastest compact SLS printer on the market. Of course, we have been doing comparisons with others, not only the software simulations, but also printing time. And yes, we managed to build really the fastest printer, the fastest compact SLS solution available. Now, the other aspect of engineer's perspective when you are looking on what is important when you are considering having and owning SLS 3D printing system are also the features of the printouts that are specifically important for you. So sometimes you will need printouts that will have very fine details. Sometimes you will require extra rigidity of the printout, whereas details will not be that important. Sometimes you will want to print with a material that can be dyed in other to achieve other colors. Sometimes you need something that will be simply soft to touch or simply flexible. Of course, we are developing a very wide line of materials and we keep working on it, but we never forget about these particular aspects. So different projects, there will be different material needs from your side. We would like to take a few words also about the materials and how they combine these different features for the projects and printouts. Radek will tell you a bit more about the range and how what is the best solutions if you need different aspects.
Thank you very much, Dominic. You nailed it because this is our approach. So we try to hear our customers, hear our anyone who is interested in laser sintering, and we learned that there is no the same application for our customers. So some of you would like to have super smooth, detailed printouts, and therefore we have in our range PA12 smooth. Some of you would like to have water-resistant printouts with high chemical resistance. This is why we have polypropylene in our portfolio as well. Those parts from polypropylene can be welded together as well, which is additional benefit. So there are many projects which requires different materials. Therefore, we need flexibility in our portfolio and in our approach. Therefore, for ones who would like to have a flexible material and their application requires a flexibility, we have a range of flexible materials. such as the materials which can allow you to adjust the hardness of the material. You can adjust it in Synthread Studio. For FlexaGray, it can be more rigid or more flexible. Also, we have a material which can allow you to have an application such as skin touch and with very low shore hardness. Also, for ones who like to dye a printout or the final product to color it, there are powders like FlexaBright. Of course, some of you would like to have something which is flexible, but also have this water tightness and air tightness. So TP comes to play at this stage because it allows you to have a flexible material, and after sealing it, you can have it watertight and airtight, which is phenomenal, I think. So, well, I think that Valentin can take us through the powders that we have thanks to Forward AM by BASF, which is our PA11 range.
Thank you, Radek, and thank you also, Dominic, for the previous information on the Lisa X system. So, as said from Radek, we work together with Synthread to provide high-performance powders from BASF Forward AM through Synthread. And the PA11 range is a bio-derived series, and actually could be an alternative also to PA12 if you need the mechanical behavior of it. So it has an exceptionally high ductility and impact strength, which makes it very interesting for applications that require deformation or a certain toughness. With the range we offer currently, you have the PA11 Onyx, so the standard PA11, but also if you need more rigid material, or let's say for lightweight application, nice example are drones. We also have a carbon fiber reinforced PA11 that Synthread currently offers. And that's definitely very interesting for lightweight structures. Then, in addition to that, also the ESD. So you see, we look into different application to specialize the powder for that, and that's the electric static discharge and also the chemical resistance in that case, which makes it very interesting. Also to mention the skin safety. So for an application with all the requirements I just mentioned, such as sunglasses, for example, that could be very interesting as well. So everything close to the body. With that, I hand over back to Dominic.
Thanks, Valentin. Thanks a lot for the information. Yes, this is actually a very interesting line of materials. I will show you some example in a minute. But just to get back to the line, to the specific requirements that we are meeting, because we speak a lot with our customers, with end customers, also with the distributors, and whenever we are going to trade shows, we also have a chance to meet real life requirements, to see the samples brought by the end clients and to have a chat. That's why we learned that dimensional tolerances and dimensional stability is also a key feature for the SLS 3D printer. To be very honest, it's achieving great dimensional tolerances and stability is one of the key challenges, I would say, that a manufacturer of any 3D printing equipment has. This is the bad news for us, for the manufacturer, that yes, we will have to focus and work on it and a lot. But on the other hand, the good news for the end customer is that dimensional stability and tolerances are achieved not by hardware, but by modified software, which means that whenever you've got a printer, whenever you are obtaining a machine, it will be printing better and better with time, with the next upgrades and updates of the software and firmware. This is interesting thing. I brought an example here to show you something as well, to give you a clue about the tolerances. You could see the dog bone on the slide. This is exactly this one. So I just want to show you with the caliper what are the? It should be 115. Yeah, it is for the length of this dog bone. 10. It should be 10 millimeters. Just to zero once again. 10 millimeters in wide. Yep, it's here, and 4 millimeters in its z-axis. So yeah, it's visible. Yeah. By the way, this is funny example, interesting example also from our BASF cooperation from the PA11 material. You can have a look how resistant it is. Actually, you can bend it and it's not breaking. It's PA11, standard PA11 that we are offering. So very, very interesting material. Yeah. For dimensional tolerances, also some of the clients are printing elements that require working with some other elements, and usually these are elements having some kind of thread on them. We have also such interesting sample. Actually, if you have a chance to meet us in the trade show or our distributors, they have this sample with them. It cannot catch the focus too much, but yeah, we have different threads here, 4, 6, 8, and 10 millimeters, and they're just turning on them, so everything works smoothly here. This is the dimensional stability that you can achieve with Sinterit compact line of printers, not only the industrial one that we are developing, but with LISAs and with LISA X especially. Sometimes you will be interested in printing very complicated shapes, and that's why we address this point to the design of design freedom with SLS technology for those who really don't like to be limited by the need of having support structures or very complex post-processing, etc., which is limiting you in many cases. With Sinterit solutions, you are able to print models that are very, very, very complex. Bike derailleur, famous Sinterit sample printed at once. So yeah, this is a single printout with many movable parts and springs inside. The other example are, of course, for the freedom of design, are very small details. So the elements like connectors, where you really need to have the possibility of fitting small elements combined with some wires, for example, together. Also Sinterit LISA X is offering that. But one of the most interesting features of Sinterit printouts and of Sinterit possibilities actually is the possibility of printing with flexible materials. The good news is that we not only have a line of flexible materials already, but with LISA X, we managed to improve the properties of the printouts. I also brought an example. This is a black tape printed with LISA X. So it's very thin. This is 1 millimeter, 1 millimeter of thickness, and I just want to show you how resistant it is for tearing. I will break it eventually, but yeah, very, very resistant for tearing and mechanically resistant material. This is good news for those of you who are choosing Sinterit solutions because of flexible materials. We managed to make a next step here with Flexa Gray, our flagship for material for the flexible ones. The profile will be ready very soon. We're going to be releasing it in the next month. So yeah, it will be already possible to print with it with LISA X. Now, printing freedom is also using the possibilities of the software. I mentioned already that Synterit is offering its own slicer, Synterit Studio, and within Synterit Studio Advanced, so the highest version of the software, we have lots of different parameters and possibilities of setting them up. My colleague, Jakub Malec, is our expert from using Synterit Studio, from adjusting the parameters, from preparing the models. He's the best guy to speak to if you would like to know some more details about positioning the models and getting the best results possible of the printer. So he's our expert from SLS applications, best practices for 3D printing, software options, cost estimations. If you are contacting us for making a benchmark, Jakub will be in touch with you for that. And Jakub is also doing our online demo presentations for Lisa X. So Jakub, I leave you this very interesting topic because no one can tell you better than you do about it.
Thanks, Dominic. Okay, so Synterit Studio. As Dominic said, this is a really great and powerful tool you can use to enhance your prototyping, for example. Synterit Studio gives you a lot of options. It's both easy to use if you're using the profiles for our materials, but gives you a lot of options for fine-tuning these materials to your liking. You have option to use all the parameters that we use to develop powders. You can some of these parameters can be set per model, so you don't have to set them globally. That also gives you an opportunity to develop a third-party powder. So if you find something interesting on market, you can use these parameters, referring the application note for the powder or the powder specification. You can develop a profile for this powder and use it on Lisa printers. Also, Synterit Studio have auto-nesting capabilities, so gives you an option to really smooth out your workflow. Now we have a short presentation for a couple of these parameters, a short video. So layer thickness, this is the most obvious. As you can see, there are a lot of jagged edges and rougher surfaces if we are going for 200 microns layer thickness. But if we swap to, for example, 75 microns, we can get a lot smoother edges, a lot rounder surfaces with the cost of a bit longer print time. The difference is around 4 to 7 hours in this example. So 7 hours for the lower layer height. As for advanced parameters, we have some options available for every powder, but the main event here is the custom parameters available with Synterit Studio, Advanced. As I said, we have 32 parameters. You can adjust its temperature, its time of warm-up, laser power, and geometry. All these parameters can be adjustment. You can save this profile with the name you like to give to it, and it will be visible in powder type section. You can also use our profiles as a guideline, for example, P12 or polypropylene. And as I said, you can also use these parameters to develop your own third-party powder. One of the parameters that can be set locally, so per model, is printing shells. So we can turn off printing infill in laser movement and geometry section And let's set 4 millimeters the shell thickness for this model. This is a knee from a CAT scan. After slicing, you can see in the previous section how does it look, how does it compare. So we have a model with infill on the left and with shell only on the right. So we don't have to sinter all the powder inside. That gives us lower density of model, so the model will be lighter. Also shortens the time of printing because we don't need to sinter the entire surface. This will be especially prominent for our previous generation printers, but also gives us a bit of flexibility and allows us to sometimes print more challenging models that can be, for example, printed flat because of their shape. Another example is hatch spacing. So the spacing between paths of the laser in the sintering. As you can see, decreasing the hatch spacing also decreases, increasing the space between laser paths decreases the density. So we can make this specimen, tensile specimen, float or sink. Okay, how can we benefit from LISA-X? I believe Radek will talk a bit more in depth about it. So I'll take it over. Okay.
Yeah, thank you very much, Jakub. So yeah, we are coming to the key question for today. So how engineers can benefit from using LISA-X? So we, from our experience and from talking to our customers that we have over the years that we are on the market, we found out that there are two main groups of benefits. So first is for the ones from you who are doing prototyping. So what's the benefit here using LISA-X? The first and foremost is that we have a range of material that are close to the final parts, are close to what you are used to use in your other applications and other technologies, and give you really close mechanical properties to what you require. And also very quick iterations, because in 24 hours, so every day you can have a next iteration of your product, because printing on LISA-X is very fast. So that's why you can have it really quickly. So you can reduce a lot of time for waiting for a part to be designed. And also you need only a small amount of powder to start printing with, which makes it not an expensive option for prototyping. I would rather say that you can save a lot of money using 3D printing to a full extent for prototyping. What's the second group of benefits? I would say it's for end-use parts and for small and medium-sized production. So the most important thing is that high mechanical properties and very good quality, which Dominic mentioned before, without the cost of doing injection molding. We all know that molds for injection molding can be very expensive. That's why 3D printing comes as a solution to this. Many of the parts, and I would say most of the parts that we are getting from our customers are fitting into the LISA-X build volume. So that's also very important, that you can fit most of the parts. And due to our solution, our full ecosystem, we have best cost per part in the segment, still remaining the industrial quality of the printed parts. And also what's not to be forgotten is that you can make tooling and on-demand production of the spare parts. It's especially important right now with a little bit disrupted delivery chains all over the world. So that's a key thing. But how does the LISA-X work actually? So yeah, we are going to hear from Adam who is going to show us how it works.
Hello, my name is Adam, and today I will try to show you what the printing process on Lisa X looks like. Let's start with the printer itself.
The interior is similar to the Lisa Pro, but the main difference is the size and layout of the gallery. Here we have a feed and here printing area. Now we fill the printer with the powder and we can start printing. It's really that simple. The printer is super fast, but don't wait 24 hours. I have a printout ready here. Collecting printout with an I/O box is similar to the process on Lisa Pro. Just grab the printout and take it to the powder handling station. Time to clean the print. The wonderful thing about SLS is that all you have to do is clean the printout. There are no supports and chemical treatment. All the powder goes to the station and is automatically processed. I saved your time. But sandblasting is very easy and only takes a few minutes. And here is finished printout.
Thank you.
Yeah, so I think that this was a very good information on how it looks like to use Lisa X and our other accessories that helps the process and make the process really easy and straightforward. But about pricing and delivery of the Lisa X, I will let Dominic to give you all the details. But I would like to remind you that on the bottom on the right-hand side, you can click a question tab and ask a questions that we will answer after this webinar. Dominic, please take it away.
Thanks, Radek. Thanks a lot. Now I know how Lisa X works. It's when it's available. Printer is available right now. Like we started the deliveries already, so printer is already shipped worldwide to our distributors, to the end clients as well. We are collecting feedback right now. And also lead time, approximately, this is 3 to 4 months. So for the orders accepted right now, it's going to be three maximum 4 months until we deliver these orders. And this counts for the global deliveries for all regions, not only for Europe. Now, what is the pricing? Printer only, so only the printer without any accessories. If you have been using, for example, Lisa Pro, you have all the accessories with you. Price of the printer is just below 17,000 euro or just below 22,000 US dollars. If you are in Asia, South America, or some other countries, we recommend to speak directly to the distributors there, because there might be some other fees on the way for transporting the printer. How does it compare with the other printers from our line? So we have Lisa and Lisa Pro. You can see over here. Lisa X is more expensive, but on the other hand, it's almost 10 times faster than Lisa and Lisa Pro. So it makes a huge difference when it comes to printing speed. When you want to count on the printer for your projects, like I was mentioning earlier, do these fast iterations. We think Lisa X is the best solution for that. Very important thing when you are considering purchasing any SLS equipment also is the completeness of the offer of the solution. So you will need not only a printer but a whole set of accessories for post-processing, for management of the powder. You will want to have the materials, the wide range of materials from the manufacturer. Sinterit is offering all that. So not only the printing solution, not only post-processing, but also software, powders, and many different services to make your work smooth and without and to take any worries from you. Lisa X is sold, of course, in a set. there is a discount for ordering all sets. So if you are thinking about ordering a whole solution, there is a possibility of making a good deal with ordering a full set. The pricing is just below 30,000 euro for the European Union, or just below 38,000 US dollars for North America and Asia, South America, and rest of the countries from other continents should also speak directly to the distributors, to the local distributors. This is all from our side. So thank you very much for your attention. Now we will be attentive to answer all your questions right now. I think we have around 9 minutes, so I hope we will manage to answer all of them. The first one is already here, so let's move on.
Yeah, so I can see the question. So is there an entire ecosystem of hardware necessary to manage post-processing? So as you seen probably in the video when Adam showed it, and you probably have seen what Dominic showed, that here we have entire ecosystem. So we have our offer made from, let's say, puzzles, and we have those 6 puzzles that are allowing you to be competent and allowing you to have a great result from the get-go. So we are having the printer as a core, we are having a software, we are having post-processing with the sandblaster, but we have also powder handling, which is crucial to have a clean and easy process. But also we are having them offer additional services with extended warranty and other things to keep you calm and keep you, let's say, secure for the entire duration of having the printer. Second question is, what does post-processing environment look like in terms of time, surface finish with supports, etc. So basically, you have seen in the video that we don't have the support. So the powder is self-supporting the part. So this is the reason why we can make very complex shapes, where we are able to make movable parts in one printout, and the surface finish without post-treatment, without sandblasting, is covered with the powder, which sticks to the surface, because the closer the powder is to the surface of the printout, the harder it sticks to the parts. That's why we are doing bit blasting, in order to remove all the excess powder from the surface and also from the places which are hard to access doing manual cleaning. And for the environment, as I said before, it's usually takes around 15 minutes to run the process, 30 minutes, depending on how many models you have and how complex they are to clean out. But it really depends on the models.
Yes, I have a short question. There is an hour counter function to replace the recoater wire. Very good question, because in Lisa Pro and in Lisa we didn't have it. Right now there is such function. There is such information. Yes, printer is counting every consumable's lifetime now, and it's informing user when there is a need to replace or clean any sensitive part of the printer. So yes, there is a counter function in Lisa X.
So what is the estimated lifetime of laser unit, laser and galvanometer? Basically, expected lifetime is around 36,000 hours. So it's a lot. So definitely, it's not going to be a problem for the expected lifetime of the printer. And you have to have in mind that the laser is not working for the entire duration of the printout. It only works when it's sintering. So it's really a long time.
Also, the time for Galvo is 6 to 8 years.
Yes, we have a very a question which is coming back quite frequently to us. Is it possible to use third-party powder in white only? Unfortunately, it is not. This is because of the laser wavelength and also of the power of the laser, basically of the construction, let's say, of the our version of this technology. It is not possible to even if we are able to sinter somehow some elements of such powder, they will not have properties that would be satisfactory. So we are not recommending to use white powder, and we are by ourselves also we are not offering such material. But also here it's good to mention that Sintert is offering Flexa Bright, the material which is bright, not completely white but is bright, and you can dye these models, these printouts with different colors.
I think the best temperature in the range. Is there any material available in high service temperature, 240 degrees Celsius? I believe the material with the highest HDT in our range is PA11 carbon fiber. I believe the HDT is in the neighborhood of 190 degrees. Valentin, do you remember maybe?
Yeah, I think it's 190 around that. The HTTP, I think, yeah, should be the highest then.
At this moment, we don't have PA12 with carbon fiber in our offer, but we still developing new powders. So you can always check our website for new materials coming.
I would like to add to this. If you're asking about PA12 with carbon fiber or any other material, we would love to hear from you what's the specific application or what's the specific feature that you would like to cover. Because more often than not, we can have a material in our range that covers this specific application. Or if we don't have, it gives us a good idea on where to explore and how to develop our powders range. So I will be glad if you can write us an information following up to this webinar with this information. So what's the application you would like to cover and what are the features needed? So, well, again, I will take this question, which is a very good one. So, when planned to develop nylon PA11 without inner gas, so we are focusing on having good quality materials with good mechanical properties. Therefore, we are using still our nylon 11 with nitrogen. So we first would like to ensure that the mechanical properties are there. So yeah, that's not in the plans for now, but maybe in the future.
I will pick one question now, because it's referring to this very interesting feature that Jakub presented. When printing the shell, will you then need a hole access to remove unsintered powder from the inside? That's a very good clue. Yeah, if we make a hole in the model, we will be able to remove the powder. If we don't make the hole, the powder will stay inside. So this is the question, what is important for us. If we want to recover this powder from the object, then yes, we will need to have a hole, some access to inside of the model. If not, if we are fine with having like a full solid structure of the printout, then we don't need to get the powder out. And it's worth to remember two things. Jakub already mentioned that when we are printing with shell, the powder stays inside, the model is lighter, and we have two benefits out of it. First is that we are printing faster because we don't need to sinter the powder which is inside. This is one thing. The second thing, the unsintered powder has half, like 50% is 50% less dense than a sintered powder, which means that the object will be lighter, okay, but you will have actually less powder inside, which means it will cost you less to print such element. So if you are just fine with having lighter element with powder inside, then you don't need any holes. Also, important thing here to mention, we will be developing other infill structures. This is a matter simply of developing them by our IT team, and they will be available with the next updates of Sinterit Studio Advanced.
I feel this question, we will have the similar answer to what I said before. So you are saying that important one is missing P11 glass field. If we are going to add this soon, it's probably the same answer for the first part. Is please let us know what's especially the feature that you would like to cover with P11 glass field. Is it going to be how stiff it is, or is it any other properties that you are looking for? This will help us tremendously to help you out with the application. Regarding the second part of your question, we are having, as Jakub said, an open material. So I think that's a great feature, that you can change the parameters in order to first test new powders or use third-party powders. So basically, you can use our parameters to try to have printouts from different powders.
And one thing to add here, I'm not sure if this is BA in case of the other company of Formlabs. Is it the BASF material? I'm not sure about that. And I think the question is here about PA12, not PA11. So yeah. Anyway.
Yeah, I think just to comment on here, so I think it's not disclosed where it's coming from, and it's they offer, I think, a PA12, yeah, GF. So as Radek said, it's always very interesting for us to see the kind of applications and requirements you have, and then we will look together into options to fulfill it with the current materials or also potential ones we work together on for the future.
Yeah, so is there an online tool available to simulate the print, material usage, and trying time? This is a great last question, I think, because yeah, definitely there is. Jakub, who is today with us, is our application engineer, and you can set up a call with Jakub in order to check what's the cost, how to fit your exact model, what will be the optimal position of the model, what will be the cost of powder, how many models you can fit into the printer. All of those information can be provided by Jakub. So this is possible. So please explore our website in order to have a demo presentation and to have all the information that you can have. Unfortunately, we run out of time to answer all of the questions remaining. So we are going to answer them via email if you left an email while registering. So we are going to answer those questions after the webinar in the coming days. So thank you very much, everyone, for participating. Thank you, everyone, for your attention. If you still, after this webinar, have any questions, please feel free to contact us via email or via chat on the website. It was our pleasure to talk to you today.
Thank you very much.
Thank you.
Bye, everyone. Bye, guys.